with section 3.3. Last time when we met in person, we didn't finish sections 3.3. We still have to finish average rate of change. So just give me a minute. Please give me a minute, and I will create brand new note for you guys. So what I'm trying to do, I'm trying to record myself, and also I'm using iPad to write the notes for you, so you have PowerPoints, and also hopefully the videos will help you to study and finish the semester successfully. Okay. So this is section 3.3. We continue, and I want to start with average rate of change. Of function definition. So average rate of change of function, this is the same what is a slope. So the textbook used a little different formula. I'm just going to use the slope formula because this is what we know already, and I think that will be easier for you. So let me give you the formula. So again, average rate of change is the same as slope. And you're going to see the notation delta y divided by delta x, which means change of y over change of x. And we know the slope formula, which is y2 minus y1 divided by x2 minus x1. Okay, where x1, y1, and x2, y2 are points on the graph. So let me just turn off my phone so we're not having any distractions. Again, hopefully you guys, this is new learning process for me to do those instructions online, so please stay with me. Okay, so let's start with the example. What we're going to do, find the average rate of change. Of function given with equation f of x, it's equal 3x squared. From 1 to 3. Okay. Oops. Sorry. Just give me a second. Oh, okay. Getting used to all that. Technology. Okay. From 1 to 3. So this is how we're going to do it, okay? 1 is technically our x1, okay? 3, it's our x2. So we need to find the average rate of change, which again, like I mentioned, this is just slope. So now what we need to do, we need to find y1 and y2. How are we going to do it? We're going to replace x from the equation with 1 to find y1, and we're going to replace x from equation of the function with 3 to find y2. By replacing x1 with 1 and x2 with 3. So y1 it's equal 3 times x1 to a second power, which will be 3 times x1 is equal 1 to a second power. So we're getting 3. So this is y1. y1 it's equal 3. y2 it's equal 3 times, and we're going to replace x with x2 to a second power. So that will give us 3 times, and we're going to replace x2 with 3 to a second power. So we're getting 9 times 3, which is 27. Okay, so now we have 2 points. We have x1, y1, which is the same as 1, 3, and we have x2, y2, which is 3, 27. So to find the average rate of change, we're just going to use the slope formula. So average rate of change equal, again, y2 minus y1 over x2 minus x1. So again, average rate of change equal y2, which is 27, minus y1, which is 3, divided by x2 minus x1, which is 3 minus 1. And we're going to end up with 12. So that was the example of how to find the average rate of change of the function, which technically we find 2 points which belongs to the function, belongs to the graph, 3x squared, that was the graph of the quadratic function, which is parabola. And we find y1 and y2 by replacing x with the given values. And we just find the slope. Okay. Next, what we're going to talk about we're going to talk about secant line. So this is the new definition. Secant line. Secant line. So let me just write this down for you guys, and then I will explain. Okay. So secant line is a line that intersects the curve or any type of graph in at least two points. So technically it's a line which cuts the graph. Okay, so let me just show you how the secant line can look like, so we can see what's going on. So example of the secant line. So we have a graph, and this is our graph. So let's add 2 points. This point will have coordinates x1, y1, and this one will have coordinates x2, y2. Okay, and the secant line, again, it's a straight line which intersects graph at those 2 points. So this straight line, it's a secant line. Okay, so what we're going to do in the next example, we're going to find the equation of the secant line. So like you see, the secant line, it's a straight line. So equation of secant line is just the equation of the line using slope-intercept form, which is why it's equal mx plus b. Again, we know what is b. B is just the y-intercept, not of the function, y-intercept of the secant line, and m, technically it's a slope. We're just going to use the new definition, average rate of change. Okay, so let's do one example. Let's do the example when we have to find the equation of a secant line. And again, don't forget that average rate of change, with y2 minus y1 divided by x2 minus x1. So let's do the example. Find the equation of a secant line of the function g of x, which is equal 3x squared plus 2x minus 1. From -2 to 1. So technically this is what we're going to do. I will draw the graph by the end when we'll be done with this example, but you have a function 3x squared plus 2x minus 1, which is quadratic function. We need to find the equation of the line from x equal -2, and which we already know 2 points, which intercepts the graph g of x at 2 points. So we're going to find the equation of the straight line, which we call secant line. When I would draw by the end, the graph will see that that's just a straight line which intersects our quadratic function, because 3x squared plus 2x minus 1 is just quadratic function. So how are we going to do it? Let's start with step 1. Step 1, okay? We know that -2 is just x1. 1 is just x2. So what I want you to do, we need to find y1 and y2 to be able to find the average rate of change, which is the slope, and use the slope formula. Find y1 and y2 by replacing x with, and again for y1 with -2, and to find y2 you'll replace x with 1. Okay, so y1 it's equal 3, and for x we're going to plug in an x1. We're going to bring that to a second power plus 2 technology plus 2 x1 minus 1. So y1 it's equal 3. Again, replace x1 with -2 plus 2 times -2 minus 1. When you will evaluate that, we'll end up with y1 equals 7. So what we have a point x1 comma y1 with coordinates -2 comma 7. Okay, so we're going to save that. To find y2, we're going to do the same thing. We're going to use the equation of the given function, and we're going to replace x with x2 and x2, again going back to that problem, x2 is just equal 1 right here. Okay, so what we having? We have y2 equal 3 times x2. We're going to replace with 1. So we have 3 times 1 to a second power plus 2 times 1. Sorry, have to buy better. Okay, I really don't want to do anything here. Oops, sorry. Technology, I'm missing you guys. 2 times 1 minus 1. Okay, when we evaluate that, we end up with y2 equal 4. So we have point x2, y2, which is 1 comma 4. So having x1, y1, x2, y2, we can just find average rate of change. So that will be our step 2. Step 2. Find the average rate of change of a secant line. So average rate of change is just slope, m it's equal y2 minus y1 over x2 minus x1. So we're going to the first lectures from our college algebra. So what we have in here, we have 4 minus 7 divided by 1 minus -2, and average rate of change will be equal to -1. Step 3, build the equation of a secant line using slope-intercept form. Which is y, it's equal mx plus b. We already know m it's equal -1. So we have y, it's equal -x plus b. To find b, you can use any of the points. We already have 2 points, x1, y1, and x2, y2. I'm just going to use the coordinates of the first point, x1, y1. So to find b, use coordinates of x1, y1, which is, what was the x1, y1? -2, 7. Okay, so let's do it. So we have y, it's equal -x plus b. I'm replacing y with 7. I'm replacing x with -2, and I'm solving for b. So we're having 7, it's equal to 2 plus b. Subtract 2 from both sides, and we're getting that b is equal 5. So y, it's equal -x plus 5 is the equation of the secant line. Of g of x, of our function, which was given by the equation 3x squared plus 2x minus 1. Okay, so algebraically maybe it's not so bad, but how that really looks like. I'm going to draw my own graph, but you guys have the graph and this example on the PowerPoint. This is the end of the section 3.3. So let's just show you guys how that looks on the graph. Okay, let's use the blue. Okay, so let's graph it. So let's graph g of x equal 3x squared plus 2x minus 1. Okay, so this is quadratic function. I'm just going to use 2 given points and find one extra. So we have x, we have y equal 3x squared plus 2x minus 1, and we have 2 points x and y. We have to find the coordinates. So again, we're going to talk about those type of functions, but right now when x is equal 0, y will be equal -1, so we have a point 0 comma -1, and I'm going to use the coordinates of the given points, which we find already, x1 and y1, which means when x is equal 1, y it's equal to 4. So again, I will just put it here that was our x1 and y1. We already find those coordinates, and I'm going to use the coordinates of the second given point, which when x was equal -2, we already find y2. So again, just give you the notes that this is x2, y2, which we use to find the equation of the secant line, and that's 7. Okay, so we're going to graph it. X, y, so I'll change to blue, so we have point 0 comma -1 somewhere here. Then we have point 1 comma 4, 2, 3, 4, and we have point -2 comma +7. -2, that was 4, 5, 6, 7, right here. And the vertex will be somewhere here. Again, I'm not talking too much about the vertex, but we will learn that soon. Okay, so that's the problem. Okay, that's the given function. Okay, and in the problem, they ask you to find the equation of the secant line, which we already find. Secant line is given by y is equal -x plus 5. That's the secant line. I told you the secant line, that's just a straight line which cuts the graph at points x1, y1. So x1, it's 1, 4, which is right here. And x2, y2, it's the point -2, 7, which is right here. So the red line will represent the equation of the secant line. So like you guys see, it's just the straight line given by the equation y, it's equal -x plus 5. So this is what we do. We just find the equation of the secant line, which is a straight line which cuts the graph when x is equal 1 and when x is equal -2, because those two x coordinates were given. Okay, so that's it of the section 3.3. I just finished the last part. With one class, I was able to talk about average rate of change. With the second class, we didn't cover that material. So hopefully the video will help you. Also, I will upload the notes on Canvas. And I want to mention to you guys that you have a PowerPoint 3.3 available on Canvas also. Please send me an email if you have any questions regarding that section. Okay, thank you. Thank you so much for staying with me.